Hey guys, happy Monday! Ready to do another great lesson on area under the curve, section 11.2. Welcome to calculus, somewhat. Okay. Um, anyhow, we're gonna figure this one out. The first one is very similar, but it's a little bit easier to do because you're simply counting how many squares really that you see area under the curve. This one's a little bit tricky, okay? In fact, I messed up the last one so bad I had to retape it because I was being silly. All right. Um, here we go. So in this one, we're going from 0 to 5, okay? So we're looking for, here's the curve, how many squares, units are under the curve here. Now notice they're not numbering by ones, okay, on the x-axis. That is a big deal, okay? So like to go for one square unit, you would go from like 0 to 1, okay? And then you would go up 1. So like this rectangle right here, this is approximately 1 square unit. Okay, if you only take half of it, that is a half a square unit because they're numbering from 0 to 1. Okay, this little tick mark here is not 1. All right, so that makes a big difference. All right, so let's see how many rectangles we got here. Okay, so this would be number 2, 2 square units. This would be number 3. We're just going to count all the whole ones for now. All right, let's see. We would have 4 here, 5 here, 4, 5, and I would say about 6 here. Okay. If you put this one and this one together, it would be 7. Oops, I don't want to do that yet, but we'll do that eventually. All right. Up here would be 7. This one would be 8. Okay, so I got 8 whole ones here. I could actually count like, here's 9. Okay, I'll just count this one as 9. All right. And then you can actually count up and down. Okay, it's the same space, right? If I go like vertical, these two squares would be 10. All right, and then there's a bunch of half squares that I haven't counted yet. All right, so like I said, if we put, let me go and switch colors here so you can see the half squares, and we'll count those a little better. Let's go with this fuchsia. I don't know what color this is, cyan. Where's the art teacher? All right, 6, 7, 8, 9. Oh, what number was that? 10. Okay, so this here would be 11. This would be 12. This is roughly 13. And then over here and here, it's 14. And I don't know. I'm just going to take a guess at 14. So, yeah, I mean, you could do it a little better than I just did. Anyhow, let's move on to the third one here. So we have to figure out the area under this curve, but we're not estimating in this one. We are approximating the area using a particular method in this one. Rather than just you counting up the squares. So it's a little bit more precise. You're still, I guess, take that back, you're still estimating. But you're estimating in a different way that's more methodical and not just counting up the squares as best as you can. So it's a little bit more precise. So you want to look at it and you think, which method am I using? Am I using the left rectangular approximation method or the right rectangular approximation method? Okay, so if you look at these rectangles, you see the top left corner is touching the curve, okay? So that tells you that I am using the LRAM, or the left rectangle approximation method. All right, and when you use the left method here, you're going to be using the smaller values of the intervals to approximate the height. Okay, because the left corner is actually what is touching the curve, so that's a little bit more accurate for determining the height here. All right, of each rectangle. So notice, okay, I have this set up. We split it up into 4 rectangles, so I have 4 different intervals. Each of them has width of 2. Okay, because 8 to 10 is 2. Okay, so I'm going to be multiplying the height by 2. Now I have to figure out precisely what the height is. All right, so since we're using the left, we're going to use the left part of our interval, which is 8. We plug 8 into the function. Here's the function, 18x minus x squared, and we get out the height of 80. Okay, I did that for 8. The next interval is 10. The next interval is 12. And the last interval, I'm going to figure out f of 14. Okay, so if I plug in 14 here, I calculate f of 14, and I get 56. Okay, 56. All right, and then to get the total area, I take the width times the height, or the base times the height. I call it width, but you could call it base. It might make more sense that way. 160, 160. This is 144. You double 56, you get 112. So the area that you should get for this is just add up all of these, and that's your answer for the left rectangle approximation method. Now, you could do the right rectangle approximation method on this, but you'd have to draw different rectangles, okay? The first rectangle that you would draw would be just to show you here, and you have to do this on your test that's upcoming. You have to be able to do both methods. So the first rectangle would look like this, okay? So you see the right corner is now touching the curve. The second rectangle would look pretty much the same as the left one, okay? The third rectangle would look like this, okay? And the fourth rectangle would look like this. Once again, you see the right corner is touching the curve. And you would actually be able to squeeze in 5 rectangles in this region here. The fifth one would look like this, and then you'd be out of the region. Okay, all right. I scratched that because we're going from 8 to 16. This first rectangle, this doesn't count. Okay, so that was an oopsie on my part. That rectangle doesn't count. We only want to use the rectangles that are in the shaded region. So, my bad on that one. All right, let's move on to a different problem here. All right, check out this one. Okay, a lot of you guys got this one partially right, and then you probably didn't get the last part right. Okay, that's the part that actually is hard and actually matters, and you need to be able to do right on your test. Okay, so you have a function. It's split up into intervals. This is very similar to the last one, but we're doing the right rectangle approximation method on this one. RAM. It tells you to do that right there. Okay, and if you look at choice A, this is not any method, okay? There aren't rectangles, so good luck. Those are trapezoids. Good luck trying to figure that one out. It's really tough. B, all right, this is not under the curve. And if you look at choice D, this is LRAM, okay? The left corner is touching the curve. All right, so you want to use C, this picture here that you see in C. All right, so to figure out the RAM estimate, all right, you have 4 different intervals, okay, 4 different rectangles. All right, the width on each one of these rectangles this time is 1, okay, so that's nice. So your height is basically the same thing as your area, because 1 times the height is equal to the area. All right, now let's go ahead and figure out the height. All right, so for our first rectangle, what are we going to use for figuring out the height? What are we going to put in our function here to figure out the height? All right, if you thought 1, you're wrong. It's not 1. Sorry, guys. This is the right rectangle approximation method. So what is actually touching the curve? It is the right point on the interval, okay? The right coordinate of the interval there. So that's 2. Okay, so you have to do f of 2 to figure out the height. All right, so then you're going to do 2 times 2 squared. So your area ends up being 8 for the first rectangle. Okay, for the next one, it's going to be f of 3. You're going to use the right again. So it's 2 times 3 squared. Okay, let me go back real quick. The height was 8. You're doing 8 times 1, so the area is also 8. All right, so this is 3 squared. 3 squared is equal to 9. Sorry, this is hard to write with this. 9 times 2 is 18. 18 times 1 is 18. So the area of the second rectangle is 18. All right, then we're going to do f of 4. f of 4 real quick would be 4 squared, which is 16. 16 times 2 is 32. So this rectangle has a area 32. The last one is f of 5. So notice we use the right in all of the rectangles, the right coordinate. Okay, because that gives you the one that's touching the curve. So makes sense. 25 times 2 is 50. So the area of this rectangle is 50. And so your total area, you'd simply add up all of the whoops. So your total area is 108 units squared for this one. Just remember this was the right rectangle approximation method. You could do it with the LRAM, it's just going to give you a different number, okay? The LRAM is an underestimate in this case. The RRAM is an overestimate. And if you want to get a better estimate, you do the average of these two, which means you add up both of the areas and you divide by 2. All right, and that's what you're doing in this last problem I'm going to show you here, finding the average of the LRAM and the RRAM methods, okay? So for choice A, you're doing the LRAM method for question A. Okay, so you have this function. You want to pick which one is showing you the LRAM. Okay, now notice choice A, the right corner is touching, so that's the RRAM, okay? Choice C, nothing is touching, it's like kind of in the middle. And choice B, the left corner is touching, so that is the right rectangle approximation method. All right, and then they want you to calculate, okay? Calculate what this actually is area-wise, all right? So once again, you're going to have to split it up into the correct intervals. All right, this one's a little bit tougher. Let me get my Epic pen going here so I can actually write on this baby. So here we go with my Epic pen. So you're going from 0 to 16. You have divided it up into 1, 2, 3, 4 intervals. So that means that this one is 4, this one's 8, this one's 12, okay? So, you know, you should set up a table, kind of like we did on the last one. So that, you know, from 4 to 8, you would have a region. All right? Now, it does say from 0 to 16, but guess what? There is no rectangle in this 0 to 4 region, okay? So, I mean, you could do 0 to 4 for our LRAM, but the area of this is going to be nothing, okay? And there's no area there. So 4 to 8, the base is 4. Okay, the height, if we're doing LRAM, we are using the left coordinate, so we would be using 4. Okay, so you would do f of 4 to figure it out. And then you plug in 4 into this function here for both x's. Then you would calculate what that is, okay? And I'm not going to take the time to do that because, you know, we saw that for the last two problems. All right, and then you're going to repeat the same thing with B, okay, only you're going to do the RRAM method, okay? And for the RRAM method, it will look like this essentially. Let me clear out all this ink. The RRAM method, you'll have a rectangle that's touching here on the outside. Okay, you'll have another rectangle that's touching the right corner of the curve there. And you'll have another rectangle that is actually going to be touching the curve right about here. Okay, so the right coordinate of each interval will be touching the curve, and the last interval from what was this, 12 to 16? Guess what? There is no rectangle that you could fit in here because it would be touching the curve right here, the right coordinate. Okay, so for each of the methods, okay, the LRAM method often will have one rectangle on the left side not touching the curve, and the right rectangular method might have a rectangle on the right side not touching the curve. All right. Either way, they're kind of averages of the actual area under the curve. If you want to be more precise, that's why we use the S symbol for infinitely many small rectangles that we could fit under there. That's the precise area under the curve for summing up all those rectangles. All right, so that's it for this video. Hope you guys have a great day, and if you want me to go over any more of this stuff better and more, just let me know. I can finish up this example, give you another example. All right, so take care now. Talk to you later. Bye-bye.